So we saw how we could use the chemistry of a tracer in water to get to the volume balance of water. And so the example that we had was old water and new water, which we're equating essentially with quick flow and base flow. So we have new water coming along the surface, old water going through the groundwater. So I mentioned chloride when we're talking about this balance, so let's use that as a tracer. So if we had rainfall, you would expect that rain would have a pretty small concentration, right? And so, of chloride. And so this concentration of chloride is going to be quite small. We would probably expect that the groundwater is going to have a much greater concentration of chloride because there's all these minerals in there that are able to dissolve. And so that's going to have a lower concentration of our tracer. So let's look at an example where we might have measured this. And in the rainwater, we came up with, for new water, right, which is rainwater, 4.5, and I'm going to use units of micromole per liter. We talked about milligrams per liter, but you can use any concentration. This again is essentially a mass per volume. It's another way that we measure concentrations in water, and you're going to find that it doesn't really matter that much which concentrations we use. And then the old water, which is essentially groundwater, has a much higher concentration. So we measured that in the groundwater to be 40.5 micromoles per liter. And then finally, if we measure in the stream what the chloride concentrations are, we have the total concentration, or the concentration of the chloride in the stream, and that turns out to be 36.0 micromoles per liter. Okay? So if I now want my fraction of new to total water, I can put in these concentrations that we measured. So we have 36.0 micromole per liter minus 40.5 micromole per liter divided by the new water, which is 4.5 micromole per liter, minus the old water again, which is 40.5 micromole per liter. And if I calculate that out, I get 0.13, which is, of course, 13%. So 13% of the water, based on these concentration measurements, we would consider to be new, right? So the concentration, or the relative amount of new water, or quick flow, compared to the total flow is 13%. So of course, the old water has to be 1 minus 0.13, which is going to be 0.87. So 87% old water. So the new water is 13%, and the old water is 87%. So most of this is mostly base flow, and so we would say that our base flow index is about 87%.